Okay, I just stopped and started the recording because I was working on Advent of Code day 5. I was finishing up from a previous session. Got part 1 done, was looking at part 2, was gonna maybe potentially not actually do it, and I was like, yeah, let's just do it. I had some ideas, so I just wanted to start a new recording for that. Okay, so kind of where I left with that was trying to figure out, you know, the rules that apply of like this, making this function of is overlap, like comparing two pairs, two ranges, and trying to see, hey, is there going to be duplicate values between these two ranges? So I was trying to work out the logic for that. I got some semblance of an idea here. Not sure if this covers all the cases or if it misses things, but I was like, let's just see if it works practically and then go from there, rather than just keep working through all the theoretical like examples. So we're just going to write that function of is overlap, and that's probably not the best name, but that's okay. So we have pair 1 and pair 2. And all we're doing based on this is saying return p1.a is less than or equal to p2.b, and p1.b is greater than or equal to p2.a. So the starting value is less than or equal to the upper value of second pair, and the second value of the first pair is greater than or equal to the starting value of that. Which I don't know if this covers everything. I feel like it doesn't, because this is almost saying, what is it saying? This value is less than or equal to this. So that lives somewhere in here, somewhere to the left of this value. Which it could also be less than this value, which in this case it is. And this value, because if this was 12 to 14, yeah, okay, I think it makes sense. We'll see though, we'll see. Let's kind of restructure our whole code here. So we're parsing this, and now let's just make a parse input part 2 just to kind of keep this for posterity. Parse input 2 for part 2. For part 1. Cool. And this time we don't need this op because we only have one parsing operation. We don't need this. We don't need this in either example. We just yeah. Okay. We don't need that in either situation. Okay. So now we're parsing, we don't need a parse available anymore. We'll just grab all our pairs like before. Beautiful. Okay. So down here, we don't need available IDs. All we need is our fresh ID ranges. We don't need that. And that'll be a little different. Let's get rid of that stuff. Let's get rid of all this junk. We can also get rid of, now that I know part 1 works, we can get rid of all this commented out code, I think. Oops. Cool. Beautiful. So we have our pairs here. Let's go on a short input first. Parse input 2. Let's see if everything works still. Parse input 2 few, oh yeah. Change the function signature or whatever it's called. Get rid of the avail IDs. What do I call this? Fresh ID ranges. Let me change that up here too. Cool. If that works. Awesome, awesome, awesome. That's kind of weird. That's kind of weird. Is there just some... Wait, what's happening? Oh, the input's different. Sure. Actually, okay, so we actually will want this, just say if blank line break. Part 2 doesn't use the second chunk of input. So just break when that's reached. If it's blank line, then we will just break. And that way we hopefully won't get a bunch of junk input. Awesome. So now that we have that, we want to will they stop bugging to get the numerator for those? We'll just call it part 2. We'll take our ranges, ID ranges. We'll just call it down here. Okay, so part 2, what we do is for each pair, I is less than fresh ID ranges size for, and we compare it to each other pair, J less than fresh ID ranges size, except we don't want to compare it to itself, so if I equals J, we'll just continue. And then we'd say our pair, which we say our P1 is, so now we have our 2 pairs that we want to compare them to, and we'd say, hey, if, well actually, first off we want the total count, raw count, the total count of fresh IDs without removing duplicates. And really what you can do, whatever. Really what we can do is say raw count plus equals, well, I guess we can do this up here. Grab this first pair here and say P1 dot A, or no, it'd be B minus A, this N minus the start. Yeah, so we get the difference between the two. So like 3 minus 5, 5 minus 3 would be 2, because that'd be plus 1. Because if we want to get how many items are there here, ignoring duplicates, like not doing anything about duplicates is what I mean. We'd say, okay, 3 to 5 is 3, 4, 5, that'd be 3 items. So 5 minus 3 is 2, plus 1 would be 3. Okay, 10 to 14 would be 10, 11, 12, 13, 14 would be 5. So 14 minus 10 is 4 plus 1. So it'd be end minus start plus 1. That's what we have here, end minus start plus 1. We then come down here and say, well, we not only want to note if it is overlap, we want to get the number of. Let's just simply see if is overlapped works. If is overlapped, because really what we want to do is modify this function and count duplicates rather than checking if it's overlapped. but that's okay. I mean, there could be a small optimization where you first check if it's overlapped, and then if it is, you count duplicates, so you don't need to count duplicates necessarily when there are none, but I don't think that'll actually be a problem in any sense. So if is overlap P1 and P2, overlap found for I want to print these out. Array, pair, print. That's how that works, right? Yeah, it just takes a pair. P1 and then also P2, and then throw in a few new lines in there. P1, line 203. Oh, it needs to be a pointer? Why? Sure. Just make it a const. Okay, hold on, I gotta take a pause real quick. I gotta go to the bathroom. All right, let's see, what was the issue? How did I fix that? Wait, what? Oh, we're printing the entire dynamic array. Yeah, okay, that makes more sense. Wait, no, I want to print a single pair. I don't need all this. Didn't I already print that somewhere? Oh, I guess it was within that, yeah. Let's say P1. So A would be something. B would be something. Okay, so overlap found for 16 to 20, 12 to 18, which makes sense. 12 to 18, 10 to 14 makes sense. Okay. Okay, one issue I'm saying is that, you know, we're doing 12 to 18, 10 to 14, but we're also doing 10 and 14 to 12 and 18. So what I think I need to do is just change this to loop from I upward. That way we're not duplicating those in that way. Because if all you really care about is compare this range to this range, no matter what order it's in, we don't need to do both orders. Because right now I'm pretty much saying compare this to this, then this, then this, okay? Then compare this to this, this, and this, okay? Next one, compare this one to this, this, this. Now, right here, if we're comparing this one to this one, that's unnecessary because previously we already compared this one to this one. We don't need to look at any of the pairs above the one we're currently on, which is what I just changed in the code. Okay. So what we can then do is change our function from is overlapped Okay, so how do we change this? Oops. How do we change this from just saying it's overlapped or not versus what are the overlaps? That's something I didn't really work out in here. Well, I was about to say, oh, what we can do is just iterate through the numbers in here and just compare if each of these values is in this range. Again, that doesn't work because the ranges in the long ones are so massive, that's impractical. So what we want to do is do some sort of math. So if we, assuming this is the correct logic, which I'm still not confident on, assuming that's the correct logic, we want to, how do we want to use that to then figure out what we need to do? So it's overlapped if the start of one is less than the end of the other, and the end of one is greater than the start of the other. I guess that's okay. That's actually what I just did with my mouse there. That's actually a really good visual way to actually understand that I think this is the correct logic right here. Because all you're saying with this check is you're saying that the start of one is less than or equal to the end of the other one. So this guy's to the left of the end of the other one. This is P1.A, P2.B. And then you're saying P1.B, wherever that is, doesn't even matter where it is. It could be here, it could be here, it could be over here, right? It's irrelevant to this. The B compared to the B doesn't matter. A compared to A doesn't matter. All we care about is wherever the B is, P2.A is to the left of that. Because by definition, we have overlap here, which means the overlap is then this section right here, which would be P1.B minus P2.A. I mean, that kind of checks out, but I'm just worried about if this is ever... Is this ever different though? Oh, this might, because you're saying 10 to 14 to 0 to... Like, is this ever reverse in a way that we'll miss something? Well, let's just write it in the code and see what happens. Okay, so this overlap is still useful because if is overlapped P1, P2, otherwise we'd return 0. Oops. Then we'll want to count duplicate. No, that's the code here. Return. Wait to return a long. Return P1.B minus P2.A. I feel like that's not going to be the whole story. Because if we're comparing 10 to 14, 12 to 18, sure, this works. What if we're comparing, though... What if we're comparing them the other way around? What if we're comparing 12 to 18 and 10 to 14? Okay, so this is P1 and this is P2. The P1.A, 12 is less than or equal to 2.B, 14 it is. And then P1.B, 18 is greater than or equal to P2.A, it is. So either way it works. And less than or equal to 18. Okay, it works either way. I don't know why I thought that was gonna be an issue. Cool. So I already know that P1.B is greater than or equal to that. This would have to be +1 as well. So if it's overlapped, we'd say duplicates. I guess no, duplicates can be an int. Count duplicates P1, P2. Duplicates found. Let's see about that. 10 to 14 would be 1, 2, 3. Then we have 6. Let's wipe some of this out. Let's just scroll down. Can I not scroll down in this? Oh, it's just tiny. Okay. 16 to 20, so, and then also 12 to 18, so 16, 17, 18. Oh, this is not gonna be right, I don't think. Oh, this is not gonna be right. Let's do 13. Oh, it only goes up to 18. Then we'd have 16. Okay, so that's interesting. So it should just be 3, but we're getting 9. Because what we're doing here is we're saying p1.b. Oh! Wait. You wouldn't want to be, because we're saying p1.b minus that. Why? Why is that what I got, and why is that not working? Maybe one is this section here. What if we know this is 5 and this is 1, 2, 3, 4, 5, 6, 7? Is it just the length of this one minus the other one plus 1? Because 7 minus 5 equals 2 plus 1 equals 3. No, that wouldn't be right, because if you had more elements down here, so you had 2 more elements, that's 3 more elements, and that'd be 8. This would be 7. You'd say, what, 8 minus 7? See, that's the thing. You had more elements over here. That would affect this value here, which is clearly not correct. But that's not how it works, but how does it work? Okay. So what comparison was I doing before? The problem is, if this is P1 and this is P2, then you're gonna do this guy minus this guy, which is like 8. However, if they were reversed, does that change it at all? Instead, you were to do P1.b minus P2.a, well, that's now 2. Interesting. Okay, that's why. So the overlaps looks like this for this first case. The overlap looks like this for the second case. Not to scale, of course, but the point is, in this one, the first one is overall larger, goes farther to the right, whereas this one, the bottom one is. What you'd want to do is subtract the B and the A over here, dependent on which one has a larger overall thing or something. Because right here we're saying, all right, subtract this guy minus this guy. Well, that should work though, right? P1.b 20 minus this Wait, did I draw that wrong? Hold on, hold on, hold on. In this case, I put this guy on the top. 16 to 20. 12 to 18. Where is this one? I put 12 to 18, 16 to 20. Wait, 16 to 20. 12 to 18, yeah. Yeah. Well, that's just not drawn to scale is what that is. Oh, what? No, you can't just draw it like that. What the fuck? I'm making my brain melt right now. Okay, 16 to 20, 12 to 18. Because you could either do, it's B minus A. So you could either do B minus A and get 2, or you could do B minus A. So you'd have to do, which B should you do? You should do the B that's smaller, right? Yeah, because you need the B that's part of the overlap. This B is not part of the overlap. This B is. This A is not part of the overlap. This one is. So, if would it always be the smaller B? Maybe. Let's just see if that works. If P1B is less than or equal to P2.B, else P1, if that B is smaller, or do return P1.B minus P2.A plus 1. Otherwise, we do P2.B minus P1.A plus 1. Is that right? Okay, we're... And we'll subtract from the duplicates. And at the end, net count let's not call it raw count, let's just call it count. And then that way it's accurate at the end. Oh, oops. Raw count is still being used. Net count 14. I felt like it was not that number. Was it? Okay, it was. What if we change this to long? Do we succeed? Nope, we sure as shit do not. Okay, so I'm gonna put a pause in that for now because it was a good attempt, but overall, the issue is that I'm not confident in my duplicate, my overlap finding logic, and especially the duplicate counting logic. Something I'm not sure about is which B and A should be subtracted. Because we got whoa, we might be getting negatives because we're using int. That might be the only issue. That actually might be the only issue. So let's at least try that and see what happens. Okay, we still got fucked. Unfortunate. Well, this guy's still that. We just need to change that to a long maybe, and then see what happens. Okay, we're still fucked. Unfortunate. So we're finding negative duplicates, which is, you know, not cash money. If P1.B, hold on, if P1.B is lesser than or equal to P2, so if this B is smaller, then we'll say this B minus this A Seems reasonable enough to me. Now are the pairs A's and B's longs? They should be. Yeah. Okay. Not sure about what should be subtractive. Just subtracted. Example to illustrate 16 to 20 and 12 to 18. If you have P1 equals 1620, then P1.B minus P2.A equals and P2 equals 12 to 18 equals P1.B would be 20 minus 12 equals 8 plus 1 equals 9, which is not the correct amount of duplicates in the overlap. So I tried to add conditionals to count the duplicates, or to, I guess, calculate the duplicates based on using the smaller b, but I'm not sure if that's consistent with what actually needs to be done to get the right answer. This works for the short input, but for long input, we get negative duplicate counts repeatedly, sometimes, which of course messes up the overall answer. I thought maybe it was just int versus long stuff, but I changed things to longs and it made no difference. Okay, it was a good college try. Put that on the back burner for now. Next time maybe I'll do a different problem, or look at this one again. We'll see, but yeah, it's a good attempt.